Why is the universe always black? Can't hundreds of millions of bright stars illuminate the entire universe? This seemingly simple question actually hides the ultimate mystery of the universe. In 1823, German astronomer Olbers raised the same question. He said that if the universe were static and homogeneous, then after a sufficiently long time, the night sky we see should be filled with bright stars, eventually achieving an effect like daytime. But in reality, although we can see a sky full of stars, overall the night sky appears dark, with large patches of darkness between the stars, and we cannot see the light of stars in these spaces. This is the dark sky paradox. How can this be explained? Olbers' answer was that at least one of the three assumptions about the nature of the universe, infinity, homogeneity, and static, is wrong. The deep space images taken by the Hubble telescope have confirmed that the structure and distribution of the universe on a large scale are uniform, without a doubt. So, is the universe finite? If the universe were finite, or if the number of stars in it were finite, then the phenomenon of a dark night sky would be easily explained, because a finite number of points of light could not fill an infinite night sky. But the question is the starry sky we see with the naked eye truly the entirety of the universe? Clearly not. First, the universe is only 13.8 billion years old, fundamentally different from an infinitely long time. Furthermore, considering the speed of light, the amount of light we can receive is finite. Light from 13.8 billion light-years away theoretically hasn't reached Earth yet. Therefore, the universe is not infinitely large, at least not the observable universe. Is the universe static? In the early 20th century, Hubble observed a crucial phenomenon, the redshift of galaxies. Almost all distant galaxies are moving away from us, and the farther away they are, the faster they recede. This means the universe is not static, but rather expanding at an accelerating rate, like an inflating balloon. Even light from the observable universe that reaches Earth will be stretched due to the expansion of the universe, eventually becoming invisible red and white lines. This is one reason why the universe appears dark to us. Moreover, not all starlight reaches Earth. According to Einstein's theory of relativity, no object with mass can exceed the speed of light. However, this does not mean that space itself cannot exceed the speed of light. Therefore, places far enough away from us can move away from us at speeds exceeding light. Consequently, we can only observe a limited number of celestial bodies and receive a limited amount of light from them. Furthermore, the energy of this light is constantly decreasing, so the night sky we see is not bright but dark.